Hello there. I'm Cindy Davis, Brand and Content Director for AV Technology. And with me today is Samuel Recine, Vice President of Global Strategic Partnerships at Matrox Video. We are here to talk about how live production is no longer just for broadcast. So, welcome, Sam. There has been a paradigm shift in live production applications in the past few years. What was traditionally a broadcast only discussion is now being incorporated into collaboration and streaming town halls within enterprise, live streaming and lecture capture in higher education, and really much more. So, what trends are you seeing from end users?
Well, the trends that we're seeing are that people have just been mixing and matching a lot of AV and IT tools. A lot of products have been able to be put into software-based workflows or software-definable workflows, and this has allowed traditionally isolated subjects like AV signal management and production and corporate communications to kind of blend with each other. So when we think of live production, in the past, that was a pretty specialized set of equipment. It was broadcasters or for live events, but the cost of that equipment has come down. The ability to do a lot of things in PC-based software has proliferated. And the result of that has been that a lot of medium-sized and large-sized organizations, schools, government, etc., have been upping the sophistication of their productions for their own internal events, for their customer trainings, for their education, for their partner communications, etc. So yeah, you expressed it really well. There's a bit of a blurring of the line there, and higher grade productions are rising because of the different ways in which they can be assembled and the decrease in cost of doing so.
So, until recently, if an enterprise or higher ed or other institution wanted to create a high quality production, they really needed a lot of staff. Have the changes in technology allowed for a reduction in staff?
Absolutely. Some of the cameras are now auto tracking and the ability to control camera angles and have cameras automatically shift to where audio is coming from with AI. All of these features just make increasingly flexible and much cheaper to productions that are pretty competent looking with a fraction of the staff as before. That's not to say that there aren't still really professional productions that still have a lot of staff. It's just that there's now the possibility of doing things that look pretty good with a smaller footprint of people and equipment.
Oh, absolutely. I agree. But this creates a lot more opportunities for production that not only looks good, but to my mind, looks pretty great compared to the DIY of the past. The rallying cry for open standards has been going on forever. And speaking of standards, SMPTE 2110 was built for broadcast. Matrox Video is a member of IPMX, the AV over IP open standard for the Pro AV market. Where do the two intersect? And please share why this is important for Matrox Video.
They intersect a great deal. So SMPTE 2110 was created as a migration path for SDI signals to IP. So what was typically used on SDI signals was YUV 42210-bit. What was typical in SDI environments is the audio, video, and metadata were separate flows that were synchronized but managed on the same cable. All of that was preserved when migrating SDI to SMPTE 2110. So the audio, video, and metadata are separate bit streams. The YUV 42210-bit is compatible. Synchronization instead of a house sync is replaced by PTP on a network. So the SMPTE 2110 standards began in the Video Services Forum as TR03. And TR03 plus a few things were taken by SMPTE and turned into the SMPTE 2110 standard. The same group that built TR03 built TR10 in the VSF and basically added some enhancements to the already existing work of SMPTE 2110. TR10 is what we refer to for simplicity as IPMX. And in TR10, there's a couple of additions that are very useful. So instead of focusing on SDI migration to IP, it addresses a broader type of signal migration, including HDMI and other consumer electronics and IT types of signals to IP using the same standards. The consequence of dealing with HDMI, for example, is it's not only a different connector plug type. The behaviors of HDMI and SDI are different. There's hot plug events. When you plug in an HDMI cable, there's automation. There's an EDID mechanism that lets the source and the display sort of shake hands and establish a resolution. Those types of mechanisms, those info frames, were added to SMPTE 2110. HDMI carries a much bigger range of display resolutions than just the broadcast SMPTE resolutions. So any multiple of 2 pixels is supported by the HDMI cable. So when you're saying you're allowing for HDMI to migrate to IP on a standard, you have to be able to support all of the resolutions that a PC can spit out. Certain things were tightened up as well. So in SMPTE 2110, it doesn't preclude you from supporting other color spaces than YUV 42210-bit, but IPMX makes RGB and YUV 444 not optional but mandatory to increase the interoperability of devices when the content isn't just camera content, isn't just broadcast resolutions, isn't just the SDI workflows, but it's maybe PC content and other things. So yeah, IPMX is basically just additions to SMPTE 2110 with a lot of utility for the types of signals that you would find outside of a typical broadcast environment. It's important to understand that there's a huge migration already happening from baseband to IP. And there's a couple of different protocols that have emerged, and they're all growing. And they all started from different places, and they all have an interesting utility. If you look at NDI, for example, NDI, the main application of NDI is to basically easily and cheaply do capture into software workflow for live production. Okay, and using an IP methodology. So instead of having a capture USB dongle or a capture card in a PC to capture a bunch of cameras, instead, you use IP cameras with the NDI protocol, and you'll load them easily into your software-based live production workflow. And then you can hit your content distribution solution with your live streams. Things like Dante proliferated differently. So this was about getting microphones to audio mixers to speakers, and migrating to IP solved all the same problems. More nodes that could be connected, and bigger distances, and basically just a lot of flexibility for how to manage audio signals. As the VOE began as a possible way to replace alternative methods of extension and switching that were doing well in the market. HD-based T, for example, is very, very popular. The HD-based T technology allows for very inexpensive extension and switching of audio and video signals. SDVOE was trying to accomplish that task using IP instead of just copper cabling, but with a proprietary signal. And with the SDVOE solution, they focused on building a chip to make it inexpensive to do something over IP. All of these things are all still growing in the market. IPMX came in as a standards-based approach, and standards are always a bit slower than first movers. There's always a first cut of something in the market that does certain things really well. IPMX has actually learned from everything that is going well in NDI, everything that is going well with SDVOE, everything that's going well with Dante, and everything that's going well with SMPTE 2110, and added a lot of those ingredients into IPMX to try to build a standards-based way of accomplishing all of the same things that these things are good at.
So then there's the HDCP discussion. Clearly, AV folks have been dealing with this for more than a decade, but things really changed when IP hit the scene. So, what do AV folks need to know about now?
A lot of people in AV know a lot about HDCP. They're experts at it. The thing to know about HDCP on IP is that already the DCP LLC defines how to deliver protected content on IP. All of the protocols that exist for doing AV over IP, all support some form of carrying protected content over IP. The problem is they all do it in a proprietary way. So the thing that's different about IPMX when we're talking about HTCP is IPMX respects the DCP LLC mechanism for doing protected content over IP, but the VSF TR10 specifications introduced a protocol called the HDCP Key Exchange Protocol. And what that was designed for is to allow a common approach for different product types from different brands to exchange the HTTP keys with each other. This is something that was missing from the market. So the ambition for IPMX is that it's possible to achieve HTTP not only within a closed ecosystem of a particular proprietary protocol, but rather that many different types of equipment from many different brands can share protected content with each other. Yeah, Matrox has focused exclusively on standards based approaches. We have KVM products, video wall products, encoders and decoders for live streaming and recording, and many different hardware and software products that are used in live production workflows and AV signal management workflows and decision making workflows. So for us, 100% of the time, the value of our product isn't what it can do on its own, but what it can do in relation to other things. So it's got to be a good citizen on a network of hardware and software from different manufacturers. It has to be possible for integrators and users to program the products and personalize the behaviors of the products to their site and to their workflow. So Matrox hugely depends on standards because in order for our products to be useful in ecosystems of related products, it's a lot easier to get things to work in an integrated system when people are following similar rules and similar implementations of technology. So yeah, we tend to read and follow standards quite a bit.
Samuel, this has been a great discussion, and I can't thank you enough for your time. It's always a pleasure.
Thank you so much, Cindy. Always a pleasure.